Jai Hind everyone. Myself Yogendra Prajapati. I am a professor from the CSC department. I am going to teach today cache memory and its mapping. Before the understanding of the cache memory, first I going to discuss about the basic memory. Today I am going to discuss memory hierarchy. Second one is the main memory. Some basic concept of the main memory. Little bit about the auxiliary memory, associative memory. Then my today topic is the cache memory. These two topics we discuss on the later on. Now, the memory hierarchy is simple. Which memory have the highest capacity in a small size and accessing time. They organize in the sequence way of the memory in the highest speed. Memory size is known as the memory hierarchy. Now, this is our memory hierarchy. The smallest memory is known as the register, and that is the highest speed. After that, cache memory its size is bigger than the register and speed is slower than the register. The third stage is the main memory. The size of the main memory is the higher than the cache memory, but the speed of the main memory is lower. And the next state is known as the magnetic disk, that is also known as the secondary memory. These three memory is known as the main memory or system memory. System memory, or that is known as the primary memory also. These three memory is also known as the primary memory. These two memory is also known as the secondary memory. This is also known as the volatile memory. This is also known as the non-volatile memory. The size of the magnetic disk comparison than these three memory is very high, and the speed of this memory is slow. Similarly, the last one is the magnetic tape. This memory is the speed of this memory is slow, but the size of magnetic tape is very high. Now we discussion on the about the some concept of the main memory. Now this is the block diagram of the main memory. The function of the main memory consists of the main 5 features. First one is the chip select 1, chip select 2. Now these 2 pin is the enable pins of the processor. These 2 pin is the function of the RAM. It means RAM perform these 2 operation, read operation and write operation. And this is one the data and address pin. It means with the help of these 2 pin, RAM are interface with the processor. Especially RAM are classified in 2-dimensional array, 2D array. For example, 128 cross 8. Now this is the 1D, this is the 2D. The first dimension of the RAM is known as the size of the memory. It means in this memory 128 number of block are available. If 128, and in each block 8-bit data are stored. In each block 8-bit data are stored. That is the meaning of the 128K cross 8. Similarly, if the size of the RAM 4K cross 8, then similarly if the size of the memory 4K cross 8, what is the meaning of this? Meaning of this, in this memory 4K number of block is available, and in each block 8-bit data are stored. This is the diagram of 4K cross 8. This is the RAM, and in each block 8-bit data are stored. And what is the meaning of the 4K? 4 into what is the K? 2 to power 10. It means 4096 total number of block is available into the RAM. It means this is the 000, here 4095 number of block are available. Now it's okay. Now this is the brief introduction about the RAM. RAM are simply classified into the two-dimensional array. First dimensional is a size of the memory, and second dimension is the size of the data. Similarly, typical ROM chip are also in a two-dimensional array. This is the size of the ROM. The first one is the size of the ROM, and the second is the size of the data. But the function of ROM have consist of the only 3 signals: chip select 1 and chip select 2, and this is the address and data bus. These two, address and data bus, is depend upon the size of the memory. Address and the data bus is depend upon the size of the memory. We discuss in the with the help of the numeric examples. Suppose the size of memory 512, suppose the size of memory 512 cross 8, then how many address line are present in this RAM, and how many address line data lines are present into this RAM or ROM? This one represent the data line of the RAM. It means the data bus of this memory is 8-bit. Similarly, the data bus of this RAM chip is also 8-bit. And what is the required address line for this RAM and this ROM? First we calculate ROM. Now there are the simple formula to find the address line of the any RAM chip or ROM chip, that is 2 to power n is equal to m. By this mathematical formula, we find the required address line for the RAM chip and ROM chip, where m is the size of the memory. And a small n is the total address line. Address line. Now this value are represented in this format. Now if 512 we convert into the 2 to power m into 2 to power, in this format it means 5 to power 9 is equal to 512. It means in this RAM total 9 address line are represented. Similarly, in this RAM 2 to power 7 is equal to 128. It means in this RAM 7 address line present, and in this ROM 9 address line present. and the both RAM and ROM chip, the data size is 8 bit. That is the complete description of the RAM and ROM chip with the help of the size and data bus. Now I am going to discuss about the RAM and ROM address mapping with the help of this diagram. Now this is the RAM chip 1, and what is the size of the RAM? Similarly 128, and the second chip of the RAM is also 128 cross 8, and the third chip of the RAM is also 128 cross 8, and the fourth chip, this is the first chip, this is the first chip of RAM, the size of RAM is similarly 128, and this is the second chip of the RAM, this is again size 128, this is third chip, this is the fourth chip, and this is the fifth chip of the ROM, and the size of RAM is 512. By the mathematical formula, we calculate the required address line for the RAM and ROM with the help of 2 to the power m. This formula, we find the address line of this RAM chip, address line of this RAM chip, address line of this RAM chip, and address line of this RAM chip, and the address line of this ROM chip. How many address line are represent? 7, 7, 7, 7, and here is a 9 address line are represent with the help of this formula we calculated. Now what is the data line are present into this RAM chip? This one is a data line, this one is a data line of the RAM chip 2, this is the data line of RAM chip 3, this is the data line of RAM chip 4, and this is the data line of the ROM chip. It means the 8 data bus. Here is also 8 data bus, 8 data bus. Here is also 8 data bus, and here is also 8 data bus. Now see that common 8, 1 to 0 to 7 data bus are connected to the each RAM and ROM chip with the CPU. CPU also consists of the read pin and write pin, and the function of the read and write pin of the CPU similarly to perform the read operation and write operation. Now the read pin of the CPU, just you see that here, are connect to the read pin of the RAM, read pin of the CPU are connect to the RAM, read pin of the CPU are connect to the RAM, and read pin of the CPU are connect to the RAM chip number 3. Similarly, the read pin of the CPU are connect to the chip number 4, and the read pin of the CPU are connect to the ROM chip. That is the point to remember. There is no function of the read operation in the ROM. So ROM operate read operation with the help of the function of the read RAM read pin. Again we will go for the next step, that is the write function. What is the write function of the CPU? To perform the write operation. Similarly, we pick a bus and connect to the WR, and WR write operation connect to the RAM chip number 1. Similarly, chip number 2, similarly chip number 3, and similarly chip number 4. This is the write operation connect to the all RAM chip, but there is no operation in the ROM chip for the write operation, so that no write pin are connected with the ROM chip. Now next step, data lines and address line. Data line I have already connected 8 data lines. What is the next part is? That is the address line. In RAM chip, how many address line are represent? Total 7 address line. 1 to 7 address line connect to the RAM chip 1. Similarly, RAM chip 2. Similarly, RAM chip 3, and similarly RAM chip 4. And this 1 to 7 address line is also connected to the ROM chip. Okay, any kind of, I think no doubt till now. Now, the interfacing of the RAM chip are completed. Only the chip select 1 and chip select 2 function are remaining. Then we take another 2 address line of the CPU, and here is a 4 chip are available into the RAM. Then we include another hardware that is known as the decoder, or the size of decoder is 2 by 4 decoder, that takes 2 inputs and produce the 4 outputs for the 4 different kind of the RAM. With the help of 2 inputs, with the help of the decoder 2 by 4, it produces the 4 output, and it is connected to RAM chip 1, RAM chip 2, RAM chip 3 and RAM chip 4. That connection is point to remember is done in the CS1. Okay. Now the one chip are remaining, that is connection is not established here. Chip number 10, line number 10 are connected the CS2, again CS2, and here again CS2, and here again CS2, and here NOT gate and CS2. It means when RAM are active, with the help of this NOT gate, ROM are not active. At the one time, only RAM, ROM are active, or RAM are active. If RAM are active, then ROM are not active. Remaining 2 address line 8 and 9, because for the ROM interfacing require total how many address line? 9 address line. Now I am connected only 7 address line, then 8 and 9 address line, 8 and 9 address line are connected to this RAM. So with the help of this diagram, we explain how the RAM and ROM chip are interfaced with the CPU. Okay. Now we take another example for the better understanding this concept. We take another example for the better understanding for this concept. Suppose the size of 2 chip RAM is 64 cross 8 and 1 chip of ROM, that is 128 cross 8. Interface these 2 RAM and ROM chip with CPU. We take another example for the better understanding for this, how the RAM and ROM are interfaced. We simply, that is the RAM 2 chip RAM. Here we draw the 2 chip RAM, that is RAM 1 and that is RAM 1 and that is RAM 2. What is the size? 64 cross 8, and here is also 64 cross 8. What is the function of the RAM? I have already discussed CS1, CS2, read, write and data and address. So now connect, this is the CS1, CS2, read, write, and similarly same function is available into the RAM chip 2, that is CS1, CS2, read, write and address. Okay. Now the one chip of the ROM, what is the size? 128 cross 8. One 28 cross 8. This is the ROM chip. And what is the function of the ROM chip? Similarly, that is CS1, CS2, and here AD. I can erase this point, no need these questions. Now here we draw the CPU. Now, what is the data line of this RAM chip and ROM chip? 8, 8, 8. It means total 8 data line present in these 3 chips. It means the 8 bit of the CPU, that is 1 to 7 data bus are interconnected with CPU to each RAM and ROM both. Now I am going to connect read function of the CPU to the read function of the RAM, and the write function of the CPU connect with the write function of the ROM and RAM chip both. Similarly, first we connect the read function. Now the read function of the CPU are connect to the read function of the RAM chip. Read function of the CPU are connect to the RAM chip 2, and there is no function of the read operation into the ROM chip, so that the read function of the CPU are interconnected to the CS1 with ROM chip. Similarly, we go for the another operation, that is write operation, and the write pin of the CPU are interface with the write pin of the RAM chip 1. Here is a RAM chip 2. Okay. Now for the third condition, we calculate the address line of chip number 1, address line the chip number 2, and the address line of the chip number 3. What is the size of the memory? We again this formula 2 to power n. For this formula, we find the total address line present into this RAM, total number line present into this RAM, and the total number of address line present into this ROM chip. Now 2 to power 6, that is 64. It means in RAM chip 1 present 6 address line. In RAM chip 2 also present the 6 address line. And what is the address line for the ROM chip? That is 2 to power 7 is equal to 128. In ROM chip present 7 address line. It means 1 to 6 address line are represent into the RAM, and 1 to 7 address line are represent into the ROM. Again, here is a 2 chip. Then with the help of decoder, we using 1/2 decoder. That is the 7, and here is a 2 output. That is the 1 cross 2 decoder. D stand for the decoder. Now here is connect chip select 1, and here connect chip select 2. Okay. Now remaining address line, that is 8, are connected with the chip select 2, and not get chip select 2. One more thing is remaining. For the RAM require 7 address line, it means for the 7 address line we also provide here, and 6 address line also we provide here. This is the complete description. This is another example for the better understanding for this numerical example. Thank you. We meet for the next classes for the another numerical problem for the cache mapping. Okay.